I'm just not able to share my screen now. Can I check? Can you check if
You should be able to. Here, let me just make sure. Let me set you as co-host. Maybe that helps.
the Zoom window is, yeah, just put it here.
Great. Well, thank you for everybody for joining today's Hyperledger meetup. We're today talking about exploring machine-to-machine payments with the Perun IoT framework. And with that, if you're all set, Mano, feel free to take it away.
Yeah, I will share my screen. Can you see my screen?
Yes.
Okay, so I just get these things out of the view. So is everything clearly visible, or is there some black areas?
It's a little bit on the side, but yeah, I can see it. It's full screen. Yeah, look good.
Okay. Yeah. Hello, everyone. Good afternoon and good morning, depending on which time zone you're joining from. I'm Manoranjith. I work as software engineer at Bosch. And today we are going to talk about machine-to-machine payments with Perun IoT framework. Welcome, everyone. Yeah, so the agenda for the meeting is in the beginning, we share our journey. It's been like 7 years since we started our project. And then we talk about our focus areas. And then we get into a very brief overview of state channels. We presented a lot about it before in different webinars. But today I just get a very short overview to get the context set for this meeting. And then we dive into the actual topic for this meeting, which is IoT state channels. First, we would look into the concept. And then I would share some info about what we did in our prior demos, which we also did in the Hyperledger forum. And third, I would present the actual demo for the day, which is the Perun Rust library for embedded devices. Yeah, to begin with, I think we started in 2017. I was still not part of the project. It was initial academic research at University of Darmstadt and Warsaw. And then papers are published on Perun state channels. And then the next year, Bosch and TU Darmstadt formed a collaboration to develop a complete state channel framework from scratch, and also develop the IoT state channels on top of it. In the following years, we released the Perun SDK, Perun Node, and eventually in 2020, the project joined the Hyperledger Labs as a Hyperledger Labs project. And also the academic team founded their startup, Polycrypt GmbH. So that was a very interesting year for us, that we solidified our mission for the next few years. And in the upcoming years, we focused on developing a lot of backends for different chains. So our first backend, which we developed until 2020, was only for Ethereum. So that was our first chain, and that's where we did a lot of concept development and so on. But once we had the concept clear, we started focusing on developing backends for other chains like Polkadot, Cosmos, Internet Computer, Servos, Cardano, Stellar, and so on. And I think currently in the last couple of years, we have been focusing on cross-chain transactions as well. I think we currently have cross-chain transaction demo set up for EVM to EVM chains. And we are also working on EVM to non-EVM chains, which is upcoming in the future. Yeah. But for the context of this demo, I think we focus on the specific use case of IoT state channels. So we presented our first demo of it in 2023, which was validating our Perun IoT architecture. The video is on YouTube. I can share the links later as well. And then today we are presenting the Perun IoT demo with actual embedded library written in Rust that can run on like really light embedded devices. So that's our journey so far, and that's the highlight on what we would discuss today. Next, I would like to share about our focus areas. One of the focus areas is IoT state channels, where devices like car, chargers, or any other IoT devices are able to make peer-to-peer payments without persistent internet connections, like really offline payments. So that is one of our focus areas. Another focus area is cross-chain transactions. So we currently have swaps available on a website called Perun X. So we could share the link as well later. You could try it out. And then we focus on payment networks and Lightning network support, like cross-chain transaction between Lightning network and other chains. And of course, as I said before, one of the other things we are working on currently is cross-chain transaction between EVM chains and non-EVM chains. So that's a second focus area. Third is payments for SSI credentials. So I think we do this on Hyperledger Aries, that you generate SSI credentials and then exchange the credentials for certain payments based on some smart contract logic. We implement that using state channels. And finally, the fourth focus area is low latency channels for game logic. Like if you have high speed online multiplayer games and you want to make really real-time transactions in the order of milliseconds or seconds, then you can either do in a proprietary backend or something that is really centralized. But with state channels, you can really use blockchain for as a backend and do direct peer-to-peer transactions within the games. So these are our focus areas. Maybe you have any questions here. I would pause for a few minutes and then proceed further. Yeah, since we do not have questions, I go forward.
I have a question. Sorry, I put it in.
Yeah, please go on.
I put it in the chat.
Yeah, well, can you read it? Would be easier.
Yeah, so I was wondering if it's possible to use IoT state channels for something other than payments, like, for example, for verified data.
Yes, so state channels allows that you can implement any arbitrary logic and make transactions based on that logic. For example, if you have some data from source, you can handle a verification logic, maybe using an oracle, and only when you hear a positive response from the oracle, you can do something else. So you can do that.
Okay, thank you.
Yeah,
Second question is, I said it also in the chat, what is Perun itself? Is it a company? Is it a product? Is it a mix of it? What is Perun?
Yeah, Perun itself is a project. So it is the state channel framework project hosted at Hyperledger Labs, and the people behind it is two people. One, we started as a a team at Bosch, and the academic team from TU Darmstadt. They initially functioned as an academic team, and then they founded their startup Polycrypt GmbH. So we both of us co-developed the Perun framework.
Okay.
Yeah, Perun itself is a project. It's not a company.
Could you explain a little bit more about EVM versus non-EVM chains? Could you explain that a little bit?
Yeah, sure. I have Henrik on the call here. Maybe he could share more insights about it. He is my colleague from Polycrypt GmbH. Yeah, Henrik, could you share your thoughts here?
Yeah, hi everyone. So yeah, to elaborate a bit on the non-EVM versus EVM problems. So we initially started doing cross-chain payments from one EVM chain to another. So this is what we also developed first on testnet, and now it's already on mainnet. And we did this together with IX6 Belcourt and also Ethereum mainnet, and we can support other EVM chains as well. And now we are working together with Stellar to develop our first EVM non-EVM pair. And we alter the Perun logic in a way that it's possible to also use our other non-EVM backends as cross-chain pairs. So this is what we're currently working on, and we're expecting to finish that, I think, in fall of this year.
So what I'm saying is it's like a FIT crypto gateway plus payment networks. You mean like the major card brands?
What do you mean card brands? I'm not sure.
Visa, MasterCard.
Oh no, it's based on blockchains that we support. We also have plans to support, for example, CBDCs, for example, the digital euro. So this is what we're playing right now, but nobody really knows what this will look like. Does it use UTXOs or does it use something else? So this is what we are currently working out with some of the leading payment companies in this space to see what the solution will look like, because most recently, it was announced that there will be some major funding from the EZB, like the European Central Bank, and that we will figure out for sure in the future, and we will also support it. But for right now, it's mainly between blockchains, so we can do swaps between different blockchain pairs. So, for example, if you're on Ethereum and you want to go to another chain, for example, Polygon, then you can say, okay, I put some ETH in the channel, and on the other side, I receive some other token. And this is completely trustless, so we're not like a centralized party, because it's all handled by the Perun protocol.
I don't want to take any more of your time. It's a fascinating discussion, because I'd like to know how that weighs up against Chainlink, but we'll save that for another time. But thank you for the explanation. I appreciate it. Thank you.
Yeah, no problem. You can also add me later, and we can have like a more elaborate discussion off-chain.
That would be
Henrik,
fantastic.
a quick question. Can you give some examples of EVM and non-EVM chains?
Sure. So EVM support is, of course, Ethereum, and then you have some other chains like Polygon. And non-EVM chains, for example, there are different types as well. So account-based chains, that would be Stellar, for example, which we are working on. And then there are also UTXO-based chains, for example, Cardano, which we also support, and at the Nervous network.
Okay. Then I have one quick question to Manoranjith, right? Yeah, my name is Chandrasekhar. I implemented solutions on Hyperledger Fabric in the financial domain for market data, KYC, and a lot of other products. So what my question is, like, in order to implement the machine-to-machine payment system, right? So what are the components involved? Just give me a high level, like you mentioned one of the thing is Hyperledger Fabric, and what else is involved in this?
Yeah, we will get into that. So that's the focus area of that's what we will get into details in this presentation. So that will come up later.
Perfect. Yeah, then continue, please. Thank you.
Yeah, sure. Yeah, so now we could proceed to the next part, if there are no more questions. Yeah. So next, here I present a short overview of the state channel protocol. Yeah, do you have any questions here?
Yeah, in the chat.
Could you read it, please? I don't have the chat open.
Is it planned that you support in the future the MENA protocol or MENA chain and zero knowledge proof technology?
Yeah, I think at least for now, we don't have it on the roadmap or plans for it right now. Maybe Henrik also can confirm this.
Yeah, there are no plans to support it, but I can look into it, because I'm not sure what the technology looks like. And for ZKP, we're also looking into that, but we want to keep state channel as a very minimal solution, so you only need signatures as like the cryptographic primitive, because zero knowledge proofs are much heavier. So this is what we are kind of trying to avoid here, so that we can also support some IoT devices, as Mano will explain soon.
Yeah, I think we come back to the state channel protocol. There are two components here. First is the layer one, which is a blockchain. And these are a bunch of different blockchain backends that we currently support for basic payment channels. And then there is the Perun channel. So what happens is, say two parties, Alice and Bob, they come to the blockchain and say, okay, here are the rules based on which we will transact with each other, and these rules are defined to a certain extent by the Perun protocol, and certain extent they're configurable. For example, how long can the arbitration take, and what are the logic that we can use, and so on. Those things are configurable. Whereas if you have some dispute, how do you resolve? If you want to consider a Perun channel opened, how do you determine that? Those things are all defined by the protocol and fixed. So initially, they would come to the blockchain and say, okay, on this backend, I want to make the blockchain layer 1 and open a state channel. And once Alice and Bob agree to that on the blockchain and lock their funds, and once their on-chain transactions are finalized, then the Perun channel can be considered open. And once the Perun channel is open, they can do direct P2P transactions with each other, as many number of payments as they want. And they can periodically update their blockchain contract in terms of, if they want to finalize. For example, if they do 10 transactions with each other and they agree that, okay, we are done, let's finalize, that we can say is a happy case. And then they can go to blockchain and say, hey, we have done 10 transactions, we want to finalize. And then it happens much faster because both parties are agreeing to the final state. On the other hand, if they say, okay, Alice is missing for some reason, and Bob has the latest state until which Alice was missing, then Bob can take that state and go to blockchain and say, hey, I can't find Alice, but we did so much transaction so far, and here's the latest proof. Can you resolve it? And then the blockchain will start the dispute process and give Alice some amount of time. This time can be configured at the time of opening of the channel. And within that time, Alice, if she has some problem, should come to blockchain and say, okay, what Bob is saying is false. I have some problem. This is my latest proof, and so on. But if it's not doing, and if the contention period lapses, then the state is finalized, and according to state which Bob submitted, the funds will be distributed and the logic will be executed, and then it is settled on the blockchain. So that's a very high level overview of how state channel protocol works. In terms of benefits, I think on blockchain, transactions are secure. Once you do it, it's done if it's finalized. And then it's also trustless. You don't trust a single party, but you trust the consensus algorithm. If we look at Perun's channels, it is also trustless. It's also secure, because if both parties agree to a certain state, then that state can always be resolved on the blockchain. But in addition to it, it provides cheap transactions, instant transactions. Like if both parties sign a particular state, then that transaction is immediately finalizable on the blockchain. So it's really instant, and they pay no fees because it's only two parties directly interacting. So it's cheap. Also, it's private and it's offline. For example, they do not have necessarily an internet connection, but they can have a P2P network, say, for example, direct P2P or Bluetooth or whatever. And then they can just do the off-chain transactions. And only for finalizing or opening, they need a connection to the blockchain via internet. So it's really cheap, instant, private, and offline. Yeah, maybe some questions here. We can take it and then proceed.
So offline in the sense, like you mentioned, no internet connection, right? So how does this work? Like they do a transaction, and when they go online, then they sync with the ledger, or how does this work?
Yes, the details of the protocol again, I will show in the next slide. So how is it offline? How the dispute works? That part I will get into details the next part of the presentation. And if you still have questions about it, we can take it at the end. Any other questions? Yeah, then we can proceed further. So this brings us to the part 2 of the presentation, which is IoT state channels. So this is state channel protocol extended for IoT use cases. So for the use case that we want to use as a basis for discussing further examples, let's consider a car at a charging station. So this car wants to go to a charging station and then charge the vehicle, and say it gets 10 units of power, and it wants to pay for each unit of power as it receives the power. So that's the context in which we will make further discussions. And in this context, if we look at the state channel protocol, what happens is that The lower part is off-chain, what happens off the blockchain, and the upper part is on-chain. So the car first makes communication with the charger and agrees on to what is the initial state that they want to build. Like okay, I want to buy 10 units of power, and I would like to pay, for example, one token per 1 unit of power. And then it makes all the agreements and generates an offline agreement. And it takes this offline agreement and goes to the blockchain and says, I want to open a Perun channel. So this is the first step, which is open. And similarly, charger also has to do its own open independently. And in the open phase, they register these initial conditions on the blockchain in the Perun smart contract. And then they also fund the channel. For example, if the car wants to pay 10 tokens over a period of like 1 hour or whatever it agrees to, then it blocks this 10 tokens in the smart contract as an escrow. It's not held to any party right now. And then the channel is considered open. So once the channel is open, the car can then, whenever it decides, it can create a state that I want to pay 1 token to the charger and create a state and directly transmit it to the charger. And when the charger signs and sends it back, this state is signed by both counterparties, and it's considered final for that point of time. And this is considered as one off-chain transaction. For this off-chain transaction, there is no internet needed, for example, to contact the blockchain, but it is sufficient that these two parties are able to communicate with each other, maybe using a local network or whatever they can think of. And in this way, whenever there is some good received, for example, some power received, it can make as many number of transactions it wants. And because this is peer-to-peer and final, the number of transactions it can make in a second also is quite high. It can make like really fast transactions. So
I just asked that question in the exact question I just asked in the what does that TPS look like?
Yeah, it is only limited by the communication and speed at which you can create communication and digitally sign the states individually. Maybe thousands are also not very difficult. It's easy because you don't have a consensus or a time lapse needed to consider state as final. If you create a state, you sign it locally, and then you send it to the other person. The other person signs it and sends it to you back. Then that state is final.
Thank you.
Yeah, so really depends on what hardware and what digital signature speed you can create. It's only limited by that. Yeah, and once, for example, if all the 10 units of power is purchased from the charger, then the car can mark the state as final. For example, the 10th state, they can say that this state is final. They mark it as final in the off-chain Perun channel, and then they take to the blockchain for settling, which is step 3. And then if they settle, it really happens faster because both parties have really agreed that it's a final state. And then that settlement happens much faster without any contention or challenge logic that's happening. But for example, if after 6 units of power are transferred, if the car says, I'm not transferring any tokens anymore, I'm not giving you payments, then the charger can say, I'm not giving you any more power. And then it can go to blockchain and say, okay, I've done 6 states. So 6th is the latest state. And it can go to blockchain and say, I want to settle. Then blockchain, Perun smart contract will open a challenge window, say, for example, 10 seconds or 10 minutes, that is really configurable at the time of opening of the channel. And within the 10 seconds, the car can have a chance to refute if whatever the charger is saying is false. Yeah, but if the time lapses, then the car does not have a chance, and then the smart contract on the blockchain settles the channel based on the latest state provided, and then the funds are redistributed. For example, initially 10 was blocked for the car and 0 for the charger, but when the channel is settled, it becomes like 4 for the car and 6 for the charger if they had a dispute, say, at 6 units of power. Or if they finished 10 units of power successfully, then it'll be 0 for the car and 10 for the charger.
And is this being done by wallet to wallet? I mean, what is the ledger, for the person doing a transaction?
Could you repeat?
Yeah. So is there a wallet that is where this is taking place is that, you know, like where are the funds held, right, that are being transferred for the exchange for the service?
Yeah, I think the wallets are also integrated as a part of Perun framework. So we have the signing everything as a part of framework.
So this assumes that the user can use like MetaMask or Coinbase as a wallet. Is that right?
Yeah, that is possible. But since we define it for machine interfaces, you can also use like programmable wallets like key value stores, key store directly, or you can also use any library wallet, not necessarily one that needs a UI.
I understand. Yes.
Yeah.
Okay. Thank you.
But we can also, so I think the Perun framework itself is built in a very modular way that you can plug in any kind of wallet, any kind of blockchain backend, or so on. So if you're interested in a particular wallet, then we can also integrate it to work with the existing systems without modifying the other parts.
Understood. Thank you.
Yeah, welcome. So this is a high-level overview of the state channels protocol. Now I share about the prior demos we present and how it relates to the current demo that we look at today. Yeah, prior demo 1. What we did was we had this setup, and for the Perun node, we had a full node that is we written in Golang. So that was our first implementation. The Go Perun full node is running on the car behalf on a computer. This computer can be anything. It can be a Raspberry Pi or even a regular computer which has an OS. So it could work. And for the charger also, we are running a full node on a different computer, and they both had a local network and so on. And then this setup was working as I explained in the before slide. So this was our first demo, the first step that we use Go Perun as full node on both sides. And from here, we did a second demo. In the second demo, we wanted to test our IoT state channels architecture. So what we did was on the charger side, we still had a Go Perun full node. By full node, I mean the way to interact with the blockchain also is integrated in the node. Like the node is responsible for off-chain transactions as well as for interacting with the blockchain to open and settle the channel. So that's what a full node means. And we configured the Go Perun as a light node by externalizing some components like the funding and watching service. And then we realized an emulation of the light node where the Go Perun is running in a light node mode that is no more having direct interaction with the blockchain. The funding and watching services are not running locally. And then it's interacting with the admin of the car. For example, it can be the user or the owner of the company which the car is a part of. It can be that, and that person is having the funding and watching services. So what happens is that the car would say to the charger, okay, here are the initial things that we want to do. So that initial logic happens directly between the car and the charger. And once it is done, it shares this information with the admin or the user, and who, based on that information, creates the does the opening of the Perun channel on the blockchain. And then what happens is the periodical transactions between the car and the charger happens as we discussed before. But one difference is, say every 3 transactions, every 4 transactions. This is really configurable on how much between how much transactions you want to update your owner. So say, for example, between every 3 transactions, it shares the off-chain state creator to the owner so that the owner knows that that is probably the latest state. And if any dispute is posted by the charger, then the owner has the latest information to challenge if there is a problem. So this was a second demo, which we presented before. The video is also on YouTube. We will share the links at the end of the presentation. This demo was to validate our IoT state channels architecture, and we were still using Go Perun just in a different configuration. And from there, we come to the current demo, where we replace the Go Perun light node with the real light node, which is written in Rust. So that library is called Perun RS. So this can really run on bare metal embedded devices. And for today's demo, I would present it on an STM32F4, which is an ARM Cortex M4 CPU. And rest of the thing is same. It's interacting with the funding and watching service. And the networking interface we use here is Ethernet. So via local Ethernet, it is contacting the funding and watching service, and the funding and watching service run by the admin is interacting with the blockchain for opening and settling of the channels. I think this answers your previous question on how payments happen offline. Maybe you have some questions further on to talk about it, then we can discuss it here.
Yeah, it addresses here. Thank you.
Yeah, okay. Yeah, I think we have a question here. What are the units and value of a Perun token or Perun unit? It really depends. So I think, for example, the IoT state channels itself, we have the implementation done currently as a demo only for Ethereum backend. So it can be, say, for example, ETH on the testnet, or yeah, it can be anything of your choice. Or you can also use a custom ERC20 token. That's why I used a very generic term as token. It can be any token, ETH or ERC, any ERC20 token. Or if you're working on some other blockchain backend, then it can be any valid token on that blockchain backend.
So what kind of hardware you need on the car, say, for example, in your example?
Yeah, for today, I'm using an STM32F4, which is basically an ARM Cortex M4 based microcontroller. This is really basic. I think it has 1 or 2 MB of memory and a very lightweight CPU. Okay,
so then we need to install the STM32 in the car or something like that, right?
No, this is just a demo. So for the Perun RS library, we have 2 components. One is the library itself that is really independent of any hardware. It is written in Rust, so you can easily cross-compile it to any hardware that supports a Rust compiler. And then we have a demo application developed on it for evaluation purposes. And this demo application has some hardware-specific components like Ethernet and everything for this STM32F4 controller. But the Perun RS library itself is hardware independent.
Yeah, I totally get it. But say, for example, right, say, take an example of Tesla. So Tesla wants to use some third-party charger. So how does Tesla interact with third-party, say, what is required? That's what my question.
Yeah, they can integrate this library into whichever microcontroller they're using. Just that they should be able to compile Rust for that controller.
So only Tesla can integrate this, right?
Yeah, whichever. So it's a library which any people who are wanting to use it can integrate it.
Okay, got it.
Yeah,
Thank
or if you're thinking about some retrofit, for example, then whoever is designing the retrofit application or the device would implement it for their hardware architecture.
Yeah, only OEM can implement this, right? That's what, if I understand.
Yeah, I don't understand how it's limited by OEM. It can be anybody who creates the device can implement it. I would say that way.
Okay. Thanks.
It's not a off-the-shelf thing that you can use right away, but it's a library, so which anybody who creates any device that wants to use the machine-to-machine payments can integrate it.
Okay.
There's another question there about what happens if the dispute is initiated.
Yeah, could you explain the question, Natalia?
Yeah, you mentioned that there is a window during which the party who has dropped off of the transaction and for whatever reason hasn't participated, part of it can initiate the dispute. So in your example, you follow the happy case when they don't do that, but what if they did? How is the dispute handled by the framework? Obviously, in your example, for example, the goods have been fulfilled, right? You cannot unwind that transaction happily. Like, what's the path forward from there?
Yeah, okay. So for example, let's say the charger transmitted 6 units of power, and the car has paid 6 units of token to the charger. And now the charger is probably not responding, let's say like that. And so the car wants to prematurely close the channel. So it says, say car is malicious. So let's make the car the bad actor. So it posts to the blockchain that I have received only 3 units of power. So my third unit is the latest, and it proposes version 3 as the latest state to the Perun smart contract. Let's say. So I think this qualifies as a dispute that you would consider, right? So car is becoming like a bad actor now.
Yep.
Yeah. Now what happens is when we create every state off chain, there is a monotonically increasing version number for each state. So by comparing the version number of 2 states, the Perun smart contract sees one state as a higher version, then it can, without any doubt, confirm that that's a later state. So now when the car submits the third state, the let's say that the challenge window is set to 10 minutes. The charger has 10 minutes to challenge and say, no, third was not the latest state, but sixth was the latest state. So what the charger would do is that it would submit, I am challenging the dispute, and sixth is latest state. Here's the proof. That is the sixth state that I created. And what Perun smart contract will do is that it will check if sixth state is valid, like does it have both signatures on the state? And then if the version number is higher than what the car submitted, and when it's higher, it says this is more valid, so I will settle according to the sixth state. So this is how the dispute resolution happens at a higher level.
Got it. Thank you.
Yeah.
Someone else asked, what are the other use cases for this?
It could be anything. For example, you have a industrial shop floor, and like where different companies want to have machines shared, and then these machines wants to interact. It could be that, or it can be anything. This is just a sample use case that I wanted to use as basis for the presentation.
And how are you going to monetize this, Hendrik? Is it Hendrik who's speaking? How's this going to be monetized?
You mean the Perun project?
Yeah.
Perun project itself is not monetized. It's an open source project. The complete source code is available on Hyperledger Labs organization, GitHub.
So it's just someone's available to use the open source, and they could monetize their use case, right?
Yeah, and I think the license also is permissive. It's Apache 2.0 license, so they can also integrate in their any proprietary device as well.
Thank you.
Yeah, but I think if you want certain specific requirements, for example, specific modifications and details, then you can reach out to one of us, and then we could help. I think Polycrypt also would be interested. Hendrik, we want to share something here?
Yeah, so I think you're completely correct, Manu, for the Perun framework itself. So how we monetize it is that we're also extending the supported backends that we do. So we continue to add functionality, and we also build services on top of so we use the framework ourselves to build services like the swapping solution. And there obviously we take a fee to develop and run the service and provide it also for others to run. So it can also run in a decentralized way, but there's a fee involved.
Just out of interest, have you guys seen any interest from parties like OEM? You mentioned Bosch was at the beginning of this. Is there adoption there or potential for adoption?
Yeah, I think I was mostly involved with development, so probably I cannot comment much here. But yeah.
Yeah, we are still in contact with a number of different companies, but we have seen adoption actually more in the Web3 space. But there's still a lot of interest and need also in the other sectors. But for sure, Web3 is much more prominent.
Thank you.
Is it planned that you connect your maybe your SSI connections or your SSI identity over to the European Digital Identity Wallet, if machine identities are not yet defined in the European eIDAS regulation, but it can be used, and Hyperledger Rise allows you with to use this SSI protocol for machines or things, IoT also. And what is your plans to integrate this in eIDAS or in other real payment solution like fiat money or a digital euro or anything else?
Yeah, I think currently we don't have plans to do it with SSI. Maybe Henrik, you want to share some thoughts here?
Yeah, sure. So we have previously integrated Hyperledger areas to do payments for credential. So it's an atomic credential payment, so no one can get cheated. So it's completely secure. But unfortunately, the eIDAS 2.0 regulation doesn't include like unknown creds. So Hyperledger areas is not within the supported types and cryptography. So that's very unfortunate. We hope that this changes in the future. But we are also for sure following the discussion around the machine specification. But for now, the focus is much more on the user side of things, so the end user and smartphones, and also secure elements within the smartphones. So we are following that closely, and will also include the digital euro if it's available, and are also in talks with, like I said, I think before, leading companies in that space regarding the developments on this.
Is there a roadmap for Perun? Is there? Like, you have a roadmap of where you're headed with the project?
Yes, but I think it's not an official one. Maybe I can I can check it and then also add it later in the link tree.
I think that would be super interesting.
Okay, sure.
Yeah, any other questions? Yeah, I think we have one question, the duration from end to end, like open, transact, and settle. I think for open, we have two parties funding the channel. So the time to open a channel is, for the initial interaction, it's really peer-to-peer, so it's not taking that much time. But open a channel, you need two blockchain transactions to be happening. So depending on which blockchain backend you use, it's really depending on that. How much time does it take to finalize a transaction for the open phase? And for transact phase, it's really flexible that you can do peer-to-peer transactions. So how long you want to keep the channel open, for as long as that time you can make as many transactions as you want. And how frequent you can do also is very use case specific. It's very configurable. And once you finish your transact phase and you want to settle, I think settle, if you're having a finalized state, if it's a happy case that you have finalized the state off chain, and if you settle, it's really one transaction that you conclude the final state on the blockchain, then it's a bit faster. But if you're not having a finalized state and if you're creating a dispute, then you make the first transaction on the blockchain calling for start dispute, and then the challenge period opens, and this challenge period is configurable for each Perun channel. So it can be 10 seconds, 10 minutes, or even days. You can really configure it as you want for the use case. And then once the challenge period, if there is some create challenge happening within that period, then the challenge period is getting extended and so on. But once the challenge period expires, then the other party can make a final withdraw transaction, and another two blockchain transactions are happening. So after that, it's time for two blockchain transactions, depending on which backend you're using. So that's roughly how much time is involved. It's really depending on the blockchain backend you're using and the configuration you're using for the channel and the use case. So the other question is, what is the minimum footprint for MCU on the IoT device? I think we test the most lightest IoT device we tested was STM32F4, which is running an ARM Cortex M4. But I think we can also try, because this we use an evaluation board for the demo today, and this board has everything like Ethernet and everything and so on board. But we can also try it on less capable hardware, and I think it should be possible to work. We have not really tested what is a lower bound.
So what's the question that you would like asked that hasn't been asked? Do you have one?
Yeah, I think there is one more question in the chat.
No, I'm saying to you, what's the question that hasn't been asked that you would like asked?
Oh, okay, the question is for me. Okay.
Yeah.
That's an interesting question.
Hendrik, do you have one?
Sorry, I was answering a question in the chat, so I didn't get it.
Is
nothing at the moment from my side.
What's the question that hasn't been asked that you would like to be asked?
It's a kind of tricky question.
It is, yeah.
Yeah.
I got nothing for now, sorry.
Okay, yeah, the project is interesting. So what I see, like, I mean, definitely somebody, the OEM should adopt this initially, or maybe the Perun project needs to work and create some kind of a use cases, and maybe so that independent entrepreneurs, right, who are interested in this, they can figure out like what is involved in this. And because my experience with I mean, you're telling the limitation is the network bandwidth, but my experience with the Hyperledger Fabric is if you want to do a real time, right? I mean, it's not practical to my experience.
Yeah,
because so much of involved consensus mechanism is involved, and again, the other challenge is you cannot take this and implement in a public domain, like somebody mentioned before, like a identity solutions in the Euro area, right? So the problem with that is you need to have the consensus, and if you don't have the ledger distributed across different parties, then you can modify the ledger anytime you like. So those are the challenges here.
Yeah, I agree to your challenge, but I think that is one thing probably which is different is in other blockchains as well, you still have can have long consensus times, but the Perun channel itself, which is between the two parties, does not depend on the consensus, because in the open phase, what it says is that, okay, here are the rules according to which we are going to play in the channel, and these rules are registered on the blockchain. And when these parties create the channel and transact in each other, they don't really interact with the blockchain at all. Because when they create each new state, they can confirm that that's the latest state, because it will have an increasing version number as the state progresses. And both the counterparties, since these are the only two parties involved, both these counterparties digitally sign the state with off-chain keys that are registered during the open phase. So that's why I said it's limited only by network bandwidth and speed at which they can create digital signatures for the transact phase alone.
Yeah, I totally agree from the parent perspective.
Yeah.
But at some point in the time, right, you have to settle it, right?
Yeah, at that point, it is not.
Yeah.
Yes, at that point, you interact with the blockchain.
Yeah.
So then you have, as I said, the challenge period, and then the blockchain transaction time and so on is involved.
Yep. It's interesting project.
Yeah. Yeah, and I think for IoT state channels, the car itself need not directly connect to the blockchain either. It just wants a connection to its owner or admin who is interacting the blockchain on its behalf. So that was the most interesting thing about this extension, where we separate the on-chain and off-chain part of the protocol into two different components and run it independently.
Yeah.
Sorry, I may have missed it, but did you outline the criteria for establishing the connection? For example, is there a requirement to have internet connectivity in order to open the channels, or is it completely offline?
Yeah, to open the channel, I think in this particular use case, so in the conditions for a regular state channel and IoT state channel is a bit different. For a regular state channel like this one, both parties should be able to have some connectivity between each other to exchange their offline states. It can be any connection. And then they also should be independently connected to the blockchain, like continuously watch the blockchain to see if any dispute was registered and challenge and refute to it. So they need both direct connection to each other and connection to the blockchain, which is persistent and reliable. But if we come to IoT state channels, then the one running the light node, for example, Perun RS light node, needs only a connection with the other person. And this connection need not be persistent. It needs to be, it can be intermittent, but it needs to be only, I can get to the next slide, I think I outlined there. So here the network connection can be intermittent, like how frequent I want to make transaction with the other device. So depending on that, it can have how much reliability I want and so on. And then depending upon the initial configuration, it should periodically update its state to the user. So for example, every 5 states or every 5 seconds or every 10 minutes, whatever configuration is there in the initial phase, based on that configuration, it wants an intermittent connection to its admin. It need not have a persistent connection. That's the requirement difference for a regular state channel and IoT state channel.
Got it. Thank you for the added context and info.
Yeah, you're welcome. Is there any questions that is not answered from the chat? Because the chat has more messages now and I'm not able to find if anything is not answered yet. Yeah, I think one question is there a flow diagram of communications? Yeah, so in the end of the presentation, we share a link tree from where you can find the link to the documentation website. And there we have a sequence diagram where we clearly explain what are the messages specifically involved and what is the time limitations and so on. So the protocol is really documented in terms of diagram in the documentation website. We can share the link in the end. And description of messages also is included. So I think one question probably I wish was not asked yet was about the interoperability. I think we did a lot of presentations about it in the past, and it's still available on the YouTube. So we really have like using protocol buffers for formatting messages between the different parties. So that allows us to have different implementations easily. For example, we have a Perun Rust node here, which is implemented in Rust, and then which is interacting with the Go Perun node. So 2 different language implementations. The interoperability is enabled by using protocol buffers as the message format. And because of that, protocol buffers have really very compact encoding schemes. So the message sizes are as minimal as possible with standard encoding schemes. I think that answers your question, Mark, regarding transaction message sizes. Yeah, any more questions? Yeah, if there are no more questions, I go to the next slide, which is, so I take a step back here to just compare how the state channels compare against the requirements for the IoT state channels, which is basically an extension of the state channels for IoT use cases. First thing is the hardware. So the state channel library, which is Go Perun, needs some microprocessor with OS. It can be a computer, for example, or a Raspberry Pi with running Linux. That can also be an option. Or even some other operating system could work because it's only a Go program. So it could just work with any reasonable hardware with an operating system, which can run Go programs. Yeah. Whereas if we take the Rust library, Perun RS, the off-chain component of the library can really run on bare metal microcontrollers. The one we use for the demo today is STM32F4 329. which does not have an OS, and it really has a very simple program. But the funding and watching services, which I showed in the previous diagram, that still runs on a capable hardware with OS. That's how we are able to make it run on lightweight hardware. The second difference is the network connection. For state channels, because it has to watch the blockchain continuously to see if any state was registered and if it has to dispute and so on, it needs to really persistent and reliable internet connection. Whereas if we look at the Perun RS library, it needs only an intermittent connection, and the frequency is really depending on the configuration of the channel. It can update the other party and its owner every few minutes or seconds, or maybe if you configure a channel in a very liberal way, it can also be like once in a few hours. That also is possible. So here the internet connection is really intermittent and really configurable depending on the. The third important thing is how on-chain keys are handled. Perun full client is directly funding the channel, and it's watching and resolving disputes and settling the channel. It needs the on-chain keys to be handled on the device running the library. Whereas if we look for the IoT state channels, Perun RS, the microcontroller does not directly interact with the blockchain, for example, for funding or settling. So it does not have this will act on its behalf. So this is working for situations where the funding service is run by, for example, an owner or admin who is owning the device. Because if you look at any IoT device, it should have somebody who it is attached to, and it can delegate. So it has trust relationships. So I'm owned or administrated by this person or this entity, and so they can have access to my on-chain keys, and they can fund and settle my channels on behalf. And so that's really a trust relationship existing there. It's not a completely trust-free relationship. So that's an overview of what we saw in the previous slides and how they compare. Any questions here? Yeah. One question is, does it use the same concepts and capabilities as an extension for IoT? Is that we took the previous slide. One moment. So here, from here to here, what we did was we took the funding and watching services, we externalized it from the full node and ran it separately on a service. So this is the difference. So these functionalities separated out, and they're running separately. An interaction between the light node and the funding and watching service is happening via network. And these are protobuf messages which are happening over like TCP connection. So, but otherwise, this node for off-chain transactions is interoperable with the other full node. It uses for TCP, for example, as the communication medium for the Perun channel. And then for message formats, it uses protobuf. And for signing, it can use any wallet implementation depending on the device capability. As long as it's able to create valid signatures, there should be no problem. They are interoperable. So we focus on interoperability here, and while the capabilities are similar, how we achieve compatibility between different libraries is by focusing on the interoperability and allowing some flexibility on the implementation itself. Does that answer your question, Morgit? Yeah, is there any other questions? Okay, I will go to the demo part then, which is the real focus for today. So for the demo, I have split the screen into 3 parts. So on the top left, there is the admin portal that's running. So I have the microcontroller part running. I can show it in the screen here. So this is the microcontroller that I'm running here. It's an STM32F4 controller that is connected over network to my computer. And then that microcontroller is interacting with the admin for funding and watching services. So that funding and watching service for the car is running on the top left split. And on the top right, I have the blockchain node running. Here it's a Ganache CLI node for the Ethereum backend. And the bottom, I'm having the charger components. So on the right, I will have the node for the charger. And then the left, I will have a small UI, a text-based UI. So with that, I proceed for the demo. Yeah, I think the blockchain node is started here. And we have the Perun contracts deployed and everything. 1 second, I can move this to another screen so that it's not getting in the way. Yeah, so what I do here is I start the Perun funding and watching service for the car here. Yeah, so the funding and watching service is started here. And here, I start the node for the charger. And here, I'm starting the node for Alice. Yeah, here I'm starting node which connects with Alice. Sorry for the visibility here. I color config visible. So this is a very sample implementation UI that we have implemented to try the Go Perun. We presented a lot of details about it in the previous presentation. So I'm not getting details of this UI here. So here we can configure the URL for the Perun node, which is a node running here. So if we want to change, we can change it here, but I'm using the defaults. And the configuration file to use, the chain URL. So the chain is running here. The default URL for the chain and the on-chain address for this user, the charger. So that is, I'm using the defaults here and I'm saying connect. So once it's connected, we have a simple UI. In this UI, we have on the top the on-chain address for Alice, and then its balance. Here it's 99 ETH, so it's a really local net. And then we have time running here. And then below we have a table where we will see something's happening. And then I have a command box. So in the command box, I'm saying open with, so here Alice is the this node, and Bob is the car that is running on the microcontroller. So I say open a channel with Bob with balance of 1 and 1. So it says, so on the sample application in the microcontroller, what we do is that we use the Perun RS library, and we have implemented the application in such a way that it accepts any incoming channel connection without a delay. And then it accepts any new state that is created. And then if a channel is to be closed, then it accepts that request as well. But because it's a configurable library, you can program it as per the needs of your application. So now the channel is open. If we see here that the transactions for funding the channel is happening here. And on this, I am receiving a request for funding the channel. The channel ID is here. And then I'm receiving a request to start watching any updates for this channel on the blockchain. So these two are the requests that's coming from the car to this admin. And then the admin funds the channel and says channel is funded. So this is the first part, which is open. The open part is finished. And then the channel is ready for transactions. And the peer name is Bob, and the balance is, you can say here, same. Sorry, 1 second. Send on channel 1, 0.1 ETH. Yeah, so I sent a transaction to the and configured to accept the channel automatically. It accepted it created its digital signature and sent the updated state back. And then we have the version number increasing now from 0 to 1, and the latest balance is 0.9 to 1.1. And now it's also possible that I can send a transaction from the microcontroller. I'm pressing a button to do that. So I'm initiating a transaction from the controller now. And we see that we get a new channel proposal, which says the new balance is transferring again 0.1 tokens back. and I accept the transaction. So now our version is 2 and the balance is back to 1, 1. So now maybe I can create some more transactions, say is just send. I can try to send some more from controller probably. Send one more. Yeah, accept channel 1. So now you see we get version 3 and now we are having €1 higher than the peer. So this way we can make as many number of transactions as we want. And then finally close the channel to say close channel 1. So if we look at the admin portal, we see that for every channel update that we have done, we receive a notification here. So here I'm sending every channel update to the admin, but you can also send every 5th or every 10th update depending on the use case. Yeah, so close channel number 1 here. So when I say close, you see that there's a F here, because in this demo application, we have done that. When I say close, I send a finalized state request to the microcontroller, which the microcontroller agrees, and then it sends the finalized state back. So the close happens much faster, which is closed instantaneous. But if you're running on a mainnet or testnet, then it's really the time taken for one transaction. And here we see that our balance is more than €100 now, because we received 0.1 Ether from the other party. So this is a demo of what we did. And so back to the presentation. Yeah, any questions here? It's a bit specific to the demo.
Could you open more than one channel concurrently between the same two parties?
Yes, technically it is possible, but with the demo application that we showed today, there's only one concurrent channel possible. But if you're talking about the protocol, it's the Perun implementation itself, we can open as many number of channels as we want. And we have that demo showcased in one of our previous videos as well. We can share the link in the end, and you can check it out. It's possible.
Got it. Thank you.
With the Rust library itself, since it's a demo application, we have a limitation that we have one concurrent channel because it's a really lightweight application, and probably it's not interested in opening multi-channels. But it's doable.
Thanks.
Yeah, but on the Perun itself, you can open a number of concurrent channels, and that's already available with the current state. And demo of it also is available, which we can show as a link later. It is also possible that the car can propose a channel, so you can initiate a channel opening from the microcontroller side, and close the channel from microcontroller side. That's also possible. Yeah, with that, we come to the end of the presentation. So wrapping up, you can check out the Perun RS repository on GitHub and reach out to us if you want to know more. To find the links, you can scan this QR code from your mobile now, or you can remember the link like Linktree. It's called Perun.network. So you can go to Linktree and type Perun.network, and there we have all our links there. Yeah, I think so this is a link tree. Here you can find ways to reach us. You can find website and links to the libraries on GitHub, or links to our blog posts and documentation websites. And we also have a playlist on YouTube where we have linked our different presentations we did before, most of it on the Hyperledger forum. And here, for example, we have this Hyperledger in-depth, enabling microtransactions between IoT devices. So this was what I showed as prior demo 2. Here you can find more detailed deep dives into how we implement the IoT architecture. And then there's other presentation, for example, getting hands-on on Perun state channels. Here we dwell into the architectural framework and how it is more designed as software and so on. What are software components and how we exactly enable interoperability and extendability and so on. Yeah, so that brings us to the end of the presentation. So thank you and open for discussion. So on the call, I have Hendrik and Jens, both from Polycrypt. So if you have any questions to them, also you can ask.
Yeah, so just thinking, so, no payment conversation goes without kind of, what about fraud kind of turn to it, right? So where do you guys see the biggest risks for, kind of like fraud and misuse opportunities here? I think maybe that step that you were showing where you kind of took the key storage and kind of payment concerns out of the embedded device, I think that could have been motivated by, concerns like that. But like in general, like what challenges have you guys encountered, and what sort of concerns you've heard from your clients, and what are you guys thinking on eliminating fraud in this framework?
Yeah, that's a good question. I think when thinking about how do we realize the state channel, so basically we started with this idea that okay, there are two devices and they want to transact with each other. So they have some conditional logic, and then based on the logic, they want to make some payments. And there, the challenges we thought was one, the network connection, having a persistent connection to the internet is really challenging. With the classical state channel protocol, like even the Perun state channel protocol, you need a watching service that's running locally, and this watching service should always be online to ensure that that party or the device is not cheated. Like if there's some dispute, then it's able to refute it. So that requirement is there. So to overcome that one, we designed the watching protocol. I think if you go to our GitHub repositories and look for Perun proposals, we have detailed the watching protocol there. So it's really a very concretely described timing sequence, how frequently you can update and what determines how long this time durations can be. So we designed the watching protocol, and that is what allows us to have still a safe payment channel, Perun channel with intermittent network connection to the admin. That was one aspect.
Got it. Yeah. Go ahead.
Yeah. Second aspect was, as you said, the keys. If you're having a lot of IoT devices and going around, like if you really want to scale, the number of IoT devices is much larger than the number of humans. So you really want to minimize the risk of the IoT device being stolen, and because of that, some loss happening. So for that reason, we tried to design the funding service in such a way that the handling of on-chain keys is completely delegated out of the device, which means even if the device is lost, the most that can happen is that we cannot access the off-chain states between the latest update the device shared and the time it was stolen. Only that small window is lost. Otherwise, we can minimize the loss to only that much amount of transactions. So that motivated us to move the funding and watching service to the external hardware. And then we have a protocol as well on how frequently you can update the watching service. These are clearly described in much detail on the Perun proposals repository.
Makes sense. Thank you.
And in addition to the always online requirement, you also have a lot of code that you need to interact with the blockchain itself, be it sending of transactions or be it watching for state. It's a bunch of code you don't really want to have on an embedded device.
Yes.
Yeah, that was one point where how we were able to achieve running this light client on a very less capable hardware like STM32, that we don't run any of the off-chain components on the device. So the code footprint is also not that much. It's really minimized to what is necessary for the protocol to function safely.
Yeah, that makes a lot of sense. Thank you, guys.
Yeah, you're welcome. Any other questions?
Do we have an answer now for the question that we wanted to be asked, but wasn't asked?
So do you ask this to me?
To you and Jens.
Yeah, I think it would be the question which was asked close to the end, which was about details about the protocols and what challenges exactly we're focusing on when transitioning from state channels to IoT state channels. But it was asked, so I have nothing.
Yeah, same for me. I think that's the question. That was a really good question.
Yeah, I think it was wonderful interaction so far. So I enjoyed the discussions too.
Yeah, thank you guys for asking so many questions. That was great.
Yeah, thank you everyone for the wonderful interactions.
Great. Well, thanks everyone. And yeah, again, if you're interested in anything that's going on here, this is just the start of a conversation we can have. This is an open source project, so feel free to get involved. And, if anybody ever wants to do another one of these meetups, I'm certainly happy to help with that. And then Menno, if you could also send me the slides, I will make sure that everybody gets those. I'll send an email around with the slides, the link tree, and the link to the recording to everybody who signed up.
Yeah, sure. I could share it to you.
Great, thanks. Yeah, we had around 180 plus people sign up, so not everybody was able to dial in, so I'll send them all those resources so they're able to still see it.
Yeah, sure. That's wonderful.
Great.
Thank you so much for hosting us.
Of course. Well, I think we're set. So thanks, everyone.
Yeah, thank you, everyone. Thanks for taking the time. And thank you for hosting as well.
Of course, yeah. Yeah, hopefully we'll see everybody again at a future meetup. Okay, thanks, everyone. Bye.
Yeah. Bye.